This is the second day presentation of section 10.1, using properties of tangents of circles. So in this section, we're going to really get into the meat of the mathematics behind circles and working with tangents of circles. So first concept I need you to master is that if you have a point outside of a circle, so in this case I have point B, and I draw tangents to the circle. So I draw a tangent here going in this direction to point A, and I'm drawing a tangent going in this direction here to point C. Okay, if I take any point anywhere outside of a circle and I draw two tangents to it, okay, those segment lengths between the point and the circle's tangency, point of tangencies, are going to be equal to each other. So the distance between B and A is going to be equal to the distance between B and C. And this will work with any point that I put anywhere outside a circle. So if I put a point over here, I draw tangents up here, and I draw tangents over here, okay, these two tangents are going to be equal to each other. So that's the concept that I need you to be able to master. So let's do this mathematically. So I've got a point right here, and this point I guess I can call A, okay? And I draw two tangents to a circle. There's going to be one that goes up to the top, to this point here, and there's going to be one that goes to the bottom, to this point right here, okay? And the distances between these two lengths are going to be the same. The distance from here to here is going to be equal to the distance from here to here. So in which case I can just set these distances equal to each other. So I can just take my 2x plus 18 and set that equal to my 6x minus 6. So this length is equal to that length, right? So I'm left with this, this equation here, okay? So I can subtract 2x from both sides, so I can move the 2x over to this side, okay? So if I subtract 2x from both sides, that's going to leave me with 18 equals 4x minus 6. So all I did was just subtract 2x from either side. So 2x went here. I guess I should show that. And 2x goes here. Okay, these cancel. I'm left with just 18 on this side, and then I'm left with 6x minus 2x equals a total of 4x. And then subtract 6. So now at this point, I can add 6 to both sides of the equation. So I can add 6 here and do the same on the other side. So just bring back my algebra. All right, and then the 6's will cancel, and I'm going to be left with then 4x equals 24. And then divide both sides by 4, and I'm going to get x equals 6. So if I plug that back in, I get 2 times 6, which is 12, plus 18 would be 30 units here at the top. And then if I plug in my 6 here, 6 times 6 would be 36, minus 6 would be 30. So I'd have 30 units on both the top and bottom of this, right? So let's take a look at one that's maybe just a tad bit more involved, because we're going to start to deal with squared terms. So again, I just drew a point of tangency at a circle here and a circle here, and came to a common point here, which means these lengths here are going to be equal to each other. So I just set up. Then x squared plus 7 equals 32. And then I'm going to subtract 7 from both sides to solve this. And 32 minus 7 is 25. And now I have a squared term here, so I need to take the square root. So the square root of 25 is 5. And if I did that and filled it back in, 5 times 5 is 25, plus 7 would be 32. Okay, second concept, and this one's the one that's a little bit, I guess, more robust. A tangent, again, is just a point, or is just a line raised segment. Could be a wall, could be another circle. It touches a circle only once. Now we can go further in that definition by saying that anything that's touching that circle at one point, okay, at that point of tangency, is going to be doing so at an exact 90-degree angle, or it is perpendicular, okay? So if I have a tangent line here touching circle C, okay, at this point, that point of tangency is going to be a right angle every single time. If there's not a right angle being drawn from the center of the circle to the point of tangency, then I guess let me backtrack. So if I'm drawing a segment between the center of the circle and the point of tangency, okay, if that's not a right angle, then we don't have a point of tangency. So anytime I have a tangent and I draw a segment from that point of tangency to the center of the circle, that is always going to be a right angle. It's always going to be perpendicular. And that's a biconditional situation, so that happens in both directions. Okay, so that's why I have the phrase if and only if there. Okay, so a line, ray, or segment being tangent to a circle if and only if it's perpendicular to a radius of the circle at the point of tangency. So I hope I did an okay job of explaining that. So we can use that as a test. So I want to know if segment AC here is a tangent. I want to know if this is a tangent, okay? I know the distance between A and C is 12 units. I know the distance between A and B is 13 units. And I know the diameter of the circle is 10. So if the diameter of the circle is 10, then I want to figure out what the radius is. The radius is going to be half of 10, which means the distance between B and C is going to have to be 5 because the diameter of the circle is 10. So in order to check for tangency, I use the Pythagorean theorem. So a squared plus b squared equals c squared. Okay, so 5 squared plus 12 squared to see if that equals 13 squared. If it does, I have a right angle here. And if I have a right angle here, then I have a point of tangency because I have perpendicularity. Okay, so I just do a squared plus b squared equals c squared. So 5 squared plus 12 squared equals 13 squared. Okay. And segment BC is 5. So 5 squared is 25. CA is 12 squared, which is 144. And BA squared is 13 squared, which is 169. And if I add up 25 plus 144, I get 169. So because these numbers match, because I have a right angle, because I have a right triangle, I have a point of tangency. So the answer to this, because there's a right angle there, is yes. So that's how we do that. Okay, so in order to do some of the more advanced problems of this section, we've got to remember how to factor binomials. So bi means 2, nomial means number. If I have 2 numbers and I'm going to square those 2 numbers, I'm going to create 4 total multiplications, okay? And maybe you guys remember doing the square thing. Was this a Punnett square? So I take x plus 20 squared means x plus 20 times x plus 20. So that's x plus 20, should have the marker, x plus 20 times, I really wish I could write better, I apologize, I'm sorry, x plus 20. So there are 4 total multiplications that are going to have to happen there, okay? You're going to have this multiplication here, you're going to have this multiplication here, you're going to have this multiplication here, and you're going to have this multiplication here. So there's 4 multiplications. So x times x, so the ones here, x times x is going to be x squared. X times 20 is 20x. 20 times x is is 20x. And then 20 times 20 is 400. So the numbers that we can combine are terms that are like each other. This is a squared term. There's no other squared, so those can't be combined. These two are the same type. They have an x in them, so they can be combined together. And then the 400 can't be combined. So when I write this in decreasing degree. So I write the squared term, then the single term, and then no x's at all. So this becomes x squared plus 40x plus 400. Okay, let's try another one, except we're going to use what's called FOIL. Okay, so FOIL, x plus 3 squared is the same as x plus 3 times x plus 3. So FOIL is going to be first, outer, inner, last. So the first terms we multiply together. So x times x is x squared. The outer terms are going to be my x and 3, which is 3x. My inner terms are 3 and x, which is 3x. And my last terms are 3 and 3, which is going to be 9. And then the numbers I can combine are these two to create 6x. So this becomes x squared plus 6x plus 9. So hopefully you remember how to do this, because this is just basically a review. So same deal here. I've got r plus 40 squared is r plus 40 times r plus 40. So I've got r times r, which is the first terms is r squared. The outer terms are going to be the r times the 40, which is 40r. The inner terms are going to be r and 40, which are 40r. And then the last term is going to be 40 times 40, which is 1600. So we're going to get r squared plus 80r plus 1600 is this one multiplied out. So hopefully you're starting to remember this, or maybe you got it right away, because this is not new information, it's review. So we're going to check to figure out what's the radius of this circle. So what's r here? So if I've got a right angle here, I have a point of tangency, then I can use the Pythagorean theorem to solve this and figure out what r is. So I'm going to have r, this squared, and then 80 feet squared is going to equal this length here. And this total length here is going to be 40 feet, and r added together, r plus 40 feet. So I can set up the Pythagorean theorem. So I'm going to have r squared plus 80 squared equals r plus 40 in parentheses squared, which we just did on the previous slide. So r squared is r squared, 80 squared is 6400, and then this multiplied out, r plus 40 squared, is r squared plus 80r plus 1600. Now when we go to solve this, okay, we subtract r squareds from both sides, and those are going to just cancel. Leave us with 6400 equals 80r plus 1600. I'm going to subtract 1600 from both sides. So 6400 minus 1600 is 4800. And then I just divide by 80 and I get r equals 60. So this, in fact, here, this distance is 60 feet. And some of you may have noticed that this is actually a Pythagorean primitive. This is a 3, 4, 5 triangle, because this becomes a 60, 80, 100, or 6, 8, 10, 60, 80, 100 type triangle. All right, so same deal here. Is segment BC tangent? So we use the Pythagorean theorem. So we're going to go a squared plus b squared equals c squared. Well, the radius here is 6, so the radius here is also going to be 6. So I'm going to have 6 squared plus 8 squared and see if that equals 6 plus 4 squared. And 6 plus 4 squared is 10 squared. And this is another one of our Pythagorean primitives. So we have 6 squared is 36, 8 squared is 64, 100, or 10 squared is 100, and 64 and 36 added together is 100. So this one is a yes. All right, last problem. In circle C, radii CA and segment CA and CB are perpendicular. Lines BD and AD are tangent to circle C. What type of quad is CADB? So we're going to draw this. So we'll draw a tangent, or not a tangent, sorry, a radius CA and CB. I'm just going to show you what that looks like. And they're going to be perpendicular, so I have to have a right angle here, okay? Then I have lines BD and AD are tangent, okay? So if this is tangent, there's got to be a right angle here, and there's got to be a right angle there. And then what kind of quadrilateral is this? Okay, well, I've got 90 degrees all here, which leaves 270 degrees. So that has to be a right angle. So we have a rectangle at this point. But that is equal to that, which means in a parallelogram, opposite sides are congruent. So that has to be that. So what we have here is a square. All right, assignment. So on Thursday, I want you to do questions 18 through 21 and 35 on page 646 to 647. On Friday, I want you to do questions 24 through 26 and 36. When you've got both of those sent to me, you can send that to me as a single email.